Hi there. In this video, we're going to talk about section 1.2, exponents and radicals. This first part is going to be on exponents. So just to review a little bit from your intermediate algebra, I'm going to start with the rules of exponents. So first of all, what is exponential notation? Exponential notation allows us to write multiplication in a repeated form. So 5 cubed means 5 times 5 times 5. Right, so if you have a to the n, then that means a times a times a times a, and so on, times a n times. So in this case, in a to the n, a is called the base of the exponential, and n is the exponent. So when I write 4 to the fifth, 4 is the base, and 5 is the exponent. And this is called exponential notation. Expanded notation is when you actually write it out. So this is exponential form. And then when you say 4 to the fifth is 4 times 4, how many times? 5 times, right? So then this will be the expanded form. And we have our rules of exponents, so the laws of exponents. When you multiply the same bases, you add the exponents. So that's what the first one is, and this is called the addition rule. When you multiply the same bases, you add the exponents. When you divide the same bases, then you subtract the exponents, so that's the subtraction rule. When you have power to a power, then you multiply the exponents. And so here are some examples to help you review. And the power can be distributed to the base as long as the bases are being multiplied. And then same thing to division. And a negative exponent means you can take the reciprocal, and negative exponents here on the bottom, number 7, is you can switch them. So whatever, I usually say whatever, anytime you have a negative, it just means it belongs on the other side. So a to the minus n goes to the bottom as a to the positive n, and b to the minus m goes to the top as b to the positive m. So same thing here with the example. Notice that the 3 to the minus 2 went to the bottom as 3 squared, and the 4 to the minus 5 went to the top as 4 to the fifth. So let's try some examples of some of these rules. So other examples. If I have, for example, 5 squared times 5 to the fourth, what would I get? Same basis, so I keep the base and we add the exponents. So 2 plus 4 is 6. If I have 5 to the 0 times 5 squared, what do we get here? Bases are the same, so I keep the base and we add the exponents. So 0 plus 2 is 2. Which brings us to another thing then. What is 5 to the 0? You may already know, and if you remember, then you know what 5 to the 0 is. If you don't quite remember, then we can figure it out. And we can say, well, I don't know what 5 to the 0 is, so let's write it. But do we know what 5 squared is? Yes, 5 squared is 5 times 5, which is 25. And that's a times. Equals 5 squared, which is 25. So what do you multiply 25 by to get 25 again? And so that must be 1. So this tells us that 5 to the 0 is equal to 1. And you can do this for any problem, which really then says that a to the 0 is 1, as long as a is not equal to 0. right? 0 to the 0 is undefined, so we don't want to do that. And now that we know that, we can also talk about negative exponents in this way, right? If I have 5 to the minus 2 times 5 to the 2, now that I know what 5 to the 0 is, we can look at same basis, so we keep the base and we add the exponents. Negative 2 plus 2 is 0. And now we know what 5 to the 0 is. So 5 to the minus 2 times 25 equals 1. So what do you multiply 25 by to get 1? And so that has to be 1 over 25. So that when you multiply 1 over 25 times 25, you get 1, right? Essentially the reciprocal. What do you multiply 25 by to get 1? You multiply by the reciprocal. So this tells us that then 5 to the minus 2 is equal to 1 over 25. But notice that 1 over 25 is 1 over 5 squared. And so that's where the rule comes in. So therefore 5 to the minus 2 is 1 over 5 squared. So that's where that number 6 comes from. That if you have a negative exponent, you get the reciprocal. So like the example here has 3/4 to the minus 2, then the reciprocal of 3/4 is 4/3. So let's try some other examples simplifying exponents. So this ones will be a little bit more intricate. So say I want to simplify. Always read the instructions. What are you asked to do? So here we're going to simplify, which usually means write for exponents using positive exponents. So the first one is, say, x squared y to the minus 1 over x to the minus 5 y squared. So how do we simplify that? Using positive exponents, and also simplifying the expressions using the properties of exponents. So here I have some negative exponents. So the first thing that I am going to do is change the negative exponents to positive exponents. So notice that I have a y to the minus 1 on the top, so that's going to go to the bottom. So I'm going to say y to the minus 1 becomes y to the 1, and I still have my y squared on the bottom. And notice that I have at x to the minus 5, and so the x to the minus 5 is going to go to the top as x to the positive 5. So the ones with the green arrows are the ones that I move, and then I have my y squared on the bottom still. And now I can use the rules of exponents that says as long as you have the same base, we can add the exponents. So I'm going to have x to the 2 plus 5, which is 7, and y to the 1 plus 2, which is 3. And that will be my final answer. There are other ways you could do it. You could utilize the properties of exponents from here right away. Right, so you can say this is x to the, when you divide the same bases, you subtract exponents. Now the one thing to be careful here is that when you're subtracting, that is a negative 5, so you're subtracting a negative. So it's going to look like 2 minus a minus 5. And y minus 1 minus 2. So then there's nothing on the bottom. And so this becomes x to the 2 minus a minus 5, so it's x to the 7, and y to the minus 1 minus 2 is minus 3. And now I have a negative exponent, which means it belongs on the bottom. So I have x to the 7th over y cubed. I prefer the first way that I showed you, just because it gets rid of the negative exponents right away. And the most common mistake that I see happening is people will say, in this case, 2 minus 5. And that will be wrong, because it's really 2 minus a minus 5 if you're going this way. Alright, let's try a second example. If I'm going too fast, you can always pause the video. or on YouTube you can either slow it down or pick up the pace. So let's try this one. If I have 2x cubed y to the minus 2 over x to the minus 3 and say y to the fourth all over, I mean, all to the negative 2. So if this is the original problem, it looks a bit intimidating, right? So again, there's different things you can do, but following the order of operations is what I normally do. So the order of operations says do parentheses first and then any exponents. So following the order of operations, I'm going to work on the inside first. So this is going to become, so I'm going to leave the parentheses and the minus 2 as it is. So order of operations says do parentheses first, then exponents, and then all the other stuff, which here we don't have. So I'm going to have anything that's a negative, I'm going to send it to its opposite side. So I have an x to the minus 3, so that's going to move to the top, and I have a y to the minus 2, and that's going to go to the bottom. And so when I write them, I have my 2x cubed, and I'm bringing another x to the minus 3, so that comes to the top as x to the positive 3. And we have the y to the minus 2 goes to the bottom as y squared, and y to the fourth. And now still order of operations, do parentheses first, so you simplify what's inside the parentheses. So I'm going to have 2x to the same basis, add the exponents, x to the 6 over y, keep the base, and add the exponents to the 6 to the minus 2. And now we deal with the exponent, but the exponent kind of has two parts. It has a negative in it too. I usually do the negative first, so the negative means where I'm going to do the reciprocal. So that's property 6. So I'm going to write it as y to the 6 over 2x to the 6. And it's just coincidence that the exponents end up being the same for the x and the y. And now it's to the positive 2, right? And the negative made it flip. And now I can distribute the exponent. So I'm going to have y to the 6 squared, so 6 times 2, so that will give me y to the 12. And on the bottom, this will be a 2 squared, and x to the 6 times 2. So I'm going to have 4 x to the 12 as well. And so that will be my final answer. Now here, notice that when I distribute the exponent, and I got 2 squared, it's really because the 2 has a 1 there. So had this been, say, if I would have had y to the 6 over, say, 5 x to the 6 square, right? This is a big if. This is separate from that problem we just did. Then this would have been y to the 12 over 5 square x to the 12. So when you distribute the exponent, the constant there has an exponent of 1. And so you take that exponent to all of them. So to that one, to the exponent there, and to the exponent there. So I always distribute to the exponent. So be careful not to say 10, right? It's 5 square. Alright, the second part of this video will be dealing with radicals.